Hello friends, in this video we will be learning invertible systems and non-invertible systems. Let us begin. Let us understand what is meant by invertible and non-invertible systems. So consider some system, let's say with input equal to x of t and output equal to y of t. We know that y of t will not be exactly equal to x of t. This x of t is taken by system. Some processing is done on x of t and the result is y of t. Is that right? Now, depending upon the nature of system, there will be some relation between y of t and x of t. For example, this system can be squarer system, the system can be integrator, it can be differentiator, it can be amplifier, it can be attenuator, and so on. Okay, we can take thousands examples, right? So the point is y of t and x of t are not same. Some processing is done on x of t depending upon the nature of system, and y of t is produced. Now the point is, can I do some reverse engineering on y of t so as to get x of t again? So what I'm doing, see, I'm applying same y of t here. I'll be having some reverse engineering so as to get output as x of t, which is originally applied here. I hope you understood this. So I'm naming this system as some reverse system. Why I'm calling this as a reverse system? I'm calling it as reverse system because it is taking output y of t as input now and producing x of t, which caused y of t as output for first system. If we are able to make such system called as a reverse system and so as to get same x of t which produced y of t earlier, then such system are called as invertible system. So this system is called as invertible system. The reason this system is called as invertible system, because for this system we can make some reverse system. Okay, it is not possible every time. Let me tell you, it is not at all possible every time. I mean, for a particular system, it is quite difficult to make the reverse system. In that case, that particular system is called as a non-invertible system, right? So for a particular system, if you are able to make a reverse system, then it is invertible system. And if you are not able to do so, then the respective system is called as a non-invertible system. Means those systems for which you cannot make reverse system. Let us start with some examples, then only you'll get an idea. Question says identify the given systems whether invertible or not. So in first example, we have y of t equal to x square of t. Let us begin with this. Y of t equal to x square of t means it is a squarer system. Am I right? So let us take x of t here and y of t here. So now let's say x of t is 1. What is respective y of t? 1. Because square of 1 will be 1 itself. Let's say x of t is 2. Then of course y of t will be 4. Let's say x of t is 3. Then value of y of t will be square of 3, which is 9. Or let's say I'm taking minus 1 as x of t, because x of t can have any numerical value. Let's say it is minus 1. But again, after squaring it, you get 1. If you take minus 2, you'll get positive 4, because square of negative numbers is also positive. Let's say minus 3, then it will give you what? 9. Is that right? So this is the analysis of the system I have done. I mean, I'm just trying to get number of outputs from different inputs. Am I right? Now the question is, from this y of t, is it possible to reconstruct the original x of t? Then one can say, sir, it is very easy. How did you get y of t? By squaring input. So now if you take a root of it, you'll get original x of t again. So likewise, when I had some system called as a squarer system, now I will have a square root system which will take square root of the inputs and it will produce some output. So let us see that also. So I'm just trying to make a system where x of t will be under root of y of t. Is that right? So let us see now. So let's say when we are applying input as 1, then root of 1 will produce output as what? You know that root of any number is positive, negative, and root of that answer, which is plus minus 1. If you give 4 as input, it will have plus minus 2 as result. If you give 9 as input, again you will have plus or minus 3. For 1, again you are getting plus minus 1. For 4 input, you are getting square root of 4 as plus minus 2, and square root of 9 is plus minus 3. Is that right? So now let us see, did we get original x of t or not? Okay, I'm talking about first example. For x of t, which was positive, okay, you got y of t as 1, and when you apply this 1 to square root system, you get plus or minus 1. Am I right? So you're getting plus 1 or minus 1. Now that's the problem. You're getting plus 1 also and minus 1 also, but what you really wanted, you wanted plus 1 only. Okay, but this is quite accepted to the level where you're getting plus 1 out of plus minus 1. But you see that even for this x of t equal to minus 1, you're getting plus minus 1. Is that right? Meaning that for two different inputs, you're getting same output. I hope you are clear. For two different inputs, okay, you're getting same output. That is, see, this y of t1 was obtained from plus 1 and this y of t1 was obtained from minus 1. But when you are processing this one again, you're getting plus minus 1, and this one again, you are also getting plus minus 1. Am I right? So now there is a problem. I mean, for this plus 1, you must have minus 1 as output, and for this plus 1, you must have plus 1 as output. But in real time, you are not getting so. Is that right? Therefore, you can say that this is not a invertible system, or it is called as a non-invertible system. So how to identify non-invertible system? It's very easy. When for two different inputs, okay, look at this, for two different inputs, if you are getting same result as output, then it is called as a non-invertible system, right? Because looking at these 2 plus 1's result, it is not possible to identify for a particular person whether this one was generated by plus 1 or minus 1, because after squaring of positive numbers as well as negative numbers, you always get positive results. But for a particular positive result, whenever you take a root, you get both answers at a time, whether it is positive result or negative result. Is that right? So originally you will never know that the result, which was squared one, was originated from positive value square or negative value square. Is that right? And therefore, such system is called as a non-invertible system. Is that right? So you don't have to think about it so much. Okay. In fact, you don't have to do this rest of the process. Only here by observation you can see that for two different inputs you are getting same result, then definitely it is a non-invertible system. Even in fact you can see here, for positive 2 also you are getting 4, and for negative 2 also you are getting positive 4. So again for two different inputs you are getting same result. Every time for two different inputs, whenever you get same result, then it is 100% non-invertible system. So what is meant by invertible system? Invertible system is that system which produces distinct output for distinct input. Am I right? So outputs are never going to repeat. The moment you change the input, output will be different, right? So only those systems are called as invertible systems. Let's see more examples, then you'll get more clarity on this. Let's start with this. Y of t is equal to sine t x of t, right? Now, for example, you are having x of t here and you are having y of t here. Let's say you are applying x of 0, right? Because we don't know what is the nature of x of t here. So I have to take x of 0 as particular x of t at t equal to 0. So I would say this is one of the input x of 0. X of 0 means x of t at t equal to 0. So now we have this relation, that is y of t is equal to sine t dot x of t. So wherever there is t, just substitute equal to 0. Then it becomes sine 0 x of 0. You know that sine 0 is always 0. So what is y of t? Y of t equal to 0. So for x of 0, you got output 0. Let's say you are applying another input. Let's say x of pi. What is x of pi? X of pi means x of t at t equal to pi. Then the result is sine pi x of pi. You know that sine n pi is always 0 provided n is integer. Here sine pi is 0. Therefore, this is also going to produce 0. Again, you see that for two different inputs, you are getting same result. And therefore, we can say that this is also non-inverting system. I'm sure you got the meaning of what is meant by non-inverting system. And now let me come to another conclusion. Another conclusion is, please remember that for a particular system, when you are checking it, especially for inverting and non-invertible, whenever you have output equal to 0, please remember, whenever you have output equal to 0, it is really impossible to generate input back from 0 input. Because see, invertible systems are those systems for which you can do some reverse engineering. That is, after processing your output, you are getting your original input back. So for 0 output, you cannot get your original input. Okay, so we have no system. See, we cannot design any system which will take 0 input and will produce some output. Okay, output means that input which was responsible to produce 0. So whenever you just remember that for particular system, whenever output equal to 0, it is 100% non-inverting system. So I really don't have to take one more example, that is x of pi. At first example where x of 0 I have tested and I got output equal to 0, there and there only you can declare that it is a non-inverting system, right? Let's see one more example. So now we have y of n equal to 1 plus minus 1 to the power n x of n, right? So here I have to take different n values. Reason, this x of n is not known to me, so I cannot actually apply different inputs and I'm going to check output. Okay, so what I'll do, I'll take n equal to 0. I'll see x of n versus y of n. So let's say n equal to 0 means it is x of 0 as input. Let's say what it is going to produce. So y of n is equal to 1 plus minus 1 to the power n, and since n equal to 0, okay, it will become 1, so it becomes twice of x of 0. Is that right? Let's say at n equal to 1, that is x of 1. At x of 1, you know that minus 1 to the power 1 will be minus 1 itself. Therefore, this difference will be equal to 0 and resulting output will be equal to 0. And I said in the last example, that is last problem, whenever output equal to 0, then it is 100% non-inverting system or non-invertible system. Okay, let's say x of 3. Okay, x of 3 means what? Again, minus 1 to the power 3 is equal to minus 1 only. X of 3 means x of n at n equal to 3. Again, it is going to produce 0 result only. As you can see that for two different inputs, you're getting same result. Is that right? Therefore, such systems are called as non-invertible system. So we should not say non-inverting, we should say non-invertible. Here we say it is non-inverting. The correct is non-invertible. Now we have one more example here. Y of t is equal to cos of x of t, right? Let's say this. This is x of t versus y of t. Let's say this x of t is 2 pi. See why I'm selecting x of t equal to 2 pi, because see ultimately we have to calculate cos of theta. So we will be selecting such theta for which cos result I can write. So for 2 pi, we know that cos of 2 pi is what? 1. Because we know that cos of n pi is minus 1 to the power n. So cos 2 pi being even number, you'll get 1 as a result. If you let's say cos of 3 pi, you'll get result as minus 1. So now there is no problem. See, for different inputs, you're getting different outputs. There is absolutely no problem. Let me try one more. Let's say x of t equal to 4 pi. Then again, since 4 is even number, cos n pi will become positive 1. Again, you will get 1. Again, there is a problem. For 2 pi also, you are getting 1. And for 4 pi also, you are getting 1. So by using this 1, okay, you cannot have another system. For this one, it is going to produce result as 2 pi, and for this one it will produce result as 4 pi. We cannot design such system, right? And therefore this system is also a non-invertible system, because for two different inputs you are getting same result. Remember, invertible system is that system which produces distinct output for distinct inputs. So this is also non-invertible system. So this is all about invertible and non-invertible systems. Thank you.